Alan DeLuna. I'm the Executive Vice President of the AAS, and we are thrilled that y'all are here today for the Goddard Symposium. It's been formally supported by the Goddard Space Flight Center for over 20 years, and we thank them for their support, and we are thrilled to give them our support as we move this rather unique conference forward into the future. We appreciate all of y'all taking your time out of your busy schedules to come in and spend time with us, and then also spend time with the people who are bringing you the program. This is a unique program. It's full of meat, and I'm really thrilled to be able to be here and participate in it. I do need to thank our sponsors, and those are Ball Aerospace and Technologies, the Boeing Company, the Coalition for Deep Space Exploration, Harris Corporation, Lockheed Martin, as I said before, the NASA Goddard Center, Northrop Grumman, SGT, Space News, SpaceX, and Surrey Satellite Technology US. We thank those companies for being members of AAS and being corporate members, and if any of you are not corporate members, come and see me and we'll figure out how to fix that. You just have to write me a little check. But not to me anyway. I do need to introduce a couple of folks very significant to us in this conference. The first one is Jim Kirkpatrick. Jim is running around here somewhere. There he is, back in the back corner trying to be quiet and hide. This is Jim's 17th Goddard conference that he has put together. Jim, thank you very much. And also, this is Jim's last Goddard conference. Jim is finally retiring from AAS. He's the executive director of AAS, and now he's doing his second retirement. His first retirement was from this little intelligence organization that he helped support in the U.S. Navy. And then he was needed to find something else to do, and he came and helped run AAS for 22 or 3 or 5? 17. Okay, 17 years. Just seems like forever, doesn't it? But we're very pleased to have had Jim, and we're very thrilled that at least he's agreed that he's going to help us figure out how to continue after him. He's not leaving us quite yet. He's going to be with us at least through the ISS R&D conference, and so we'll have some opportunity to spend more time with Jim as we go forward. Now, I do have one more person to introduce, and that's Harley Thronson. Harley's the chairman of the planning committee for this conference. And if you look inside of your program, there's an insert, and it has the full list of the planning committee. I sat in on one of their, or two of their telecons, and found out that I didn't need to even say anything, which for me is very unusual. So they've done a great job putting this all together. Harley did send us some new bios for the speakers yesterday, and he made sure that he told me that these are the right bios to use, especially the one for him. So I'm just going to...
He was born in the Isle of Man in 1879. Series of awards from the Queen of
Awards, yes, yes. So when I've done coaching for theater and for speakers and things, and I've told the people that I coach, when you're doing something that's important, make sure you read it properly. Do not be afraid of your notes. Embrace your notes. Embrace your script. That way you do it correctly. So let me make sure I do this correctly. Dr. Harley Thronson has served as the planning chair for the AAS Goddard Symposium since 2009. His current responsibilities at NASA Goddard include leading the assessment of concepts for future major astrophysics missions and advanced human robotic programs beyond the immediate vicinity of the Earth. In addition to his role at the Goddard Symposium, he co-chairs the annual Humans to Mars Summit, the series of affording and achieving Mars exploration workshops, and moderates a long-running series of weekly online seminars and Google Hangouts. And if you haven't attended any of the Google Hangouts, do so. You will find them fun, informative, and absolutely amazing. He currently is in the graduate school of the Virginia Theological Seminary, as if he didn't have anything else to do. So Harley, thank you very much.
Great. Thank you.
Thank you for letting me come.
Okay, thank you. As you know, that part of my role here is to give you various instructions and some background, and if you've got issues and so forth, which I'm going to do. After our first speaker, we want to go right into one of the most exciting speakers out of many exciting speakers here at the Goddard Symposium, Dr. Matt Mountain. Many of you know of him. He is the current current president of the Association of Universities for Research in Astronomy, AURA, which is a consortium of 40 research institutions and 4 international associations. Before then, he was, for a number of years, director of the Space Telescope Science Institute. I'll have more announcements after Matt speaks. Matt Mountain.
Okay.
The password for the Wi-Fi is AAF.
Thank you. Good morning, and I have to say it was an enormous privilege to be asked to open this conference. I've worked with NASA now since about 2003, and I have to say it's been one of the most rewarding experiences of my career because of the incredible things you all do. And this talk is going to be a little bit different, but I wanted to start by acknowledging 3 friends and 3 colleagues from Goddard who left us this year, who I hope epitomize some of the values that I'll be talking about as science and exploration. Pierre Sellers, Phil Sablehouse, and Neil Garrels. Now, we all know what exploration and science can do. You know, our human ability to wonder the world in which we live, to try and imagine, to explore it further, and then ability to see something that nobody else perhaps has seen, that unifies science and exploration and a human urge to reach out. And nothing epitomizes that more than the Hubble Space Telescope, now 26 years old, which was made possible by a partnership between human spaceflight and science. And sometimes our science colleagues forget the incredible commitment the exploration and the human spaceflight program made to science. Here in 2009, May 2009, 2 shuttles on the launch pad. You know, that is a commitment to science that our community needs to understand. It's an incredible partnership. But I would actually like to take a different approach today. I'm looking out as a scientist on an audience of scientists, engineers, managers, people who actually run this great agency. And sometimes it's good just to remember some of those other values that NASA brings to us all, brings to the United States, and brings to humanity. We actually all know how images from the Hubble are made. You know, it's a camera, it happens to be flying at 17,500 miles an hour, 300 miles above our head in the vacuum of space, and it transmits images down here on Earth. But to call Hubble a camera, that it just takes pictures, is a bit like saying Ansel Adams took pictures. Ansel Adams did more than that. He tried to draw us into something that he saw, to actually share the experience of the great parks. And these are all available on Wikipedia, you can actually get them. And of course, when we create images like this, it turns out a lot of human decisions are made in these images. It's a desire not just to present a confused space, but to try and bring clarity to the image as well. The images are precisely accurate, but choices are made. And the person who does this at Space Telescope is a guy called Zsolt Levé, who's actually a great champion of Ansel Adams. And Zsolt wrote, "I try to create an appreciation that it is a larger place than the world in which we inhabit. I want people to know there is stuff to see and experience out there. And this image, in fact, is the front cover of a collection of poems by Tracy Smith. And this book won the Pulitzer Prize for Poetry in 2012. It turns out her father was an engineer that worked on the Hubble. And she wrote in this collection, "The first pictures came back blurred, and I felt ashamed for all the cheerful engineers, my father and his tribe. The second time, the optics jibed, and we saw to the edge of all there is, so brutal and alive, it seemed to comprehend us back. These emotional connections are what you do, as well as build rockets and telescopes and machines." And it wasn't just beauty that motivated Ansel Adams. It was creating a sense of frontier, an enduring American symbol of reaching out, going over that horizon, not knowing what is there. He wanted to draw everybody out and kind of unify the country to say, we are explorers, we do reach beyond the horizon. And that's what people try to do with the Hubble images. And in fact, when we were picking the 25th anniversary image, we all knew this was a star formation region, that the stars were ablating the dust and there was a jet and a planetary disk. But that isn't the decision processes we went through. We wanted to know, how could we create a landscape? How could we draw people in? And this is the 25th anniversary image we came up with. A very human decision-making process. And of course, we aren't the only one who takes pictures. This is a landscape on Mars. Don't tell me this picture was created simply to tell us what color the Martian soil was. This image was also created to generate a sense of awe and wonder and a frontier beckoning. We reach further out. The limb of the moon Enceladus out by Saturn. Water vapor spewing forth, or ice at least, spewing forth. These images have power. And they have unique power. And sometimes it's important to realize how powerful pictures are, even if they're scientifically motivated. This is not an original idea. A few years ago, the Walters Art Museum in Baltimore had an exhibition of maps and asked the Hubble Space Telescope guys to produce pictures along with it. And here was a comparison the director made. On the left is a beautiful painting of the geological strata of Great Britain, painted in 1851 by William Smith, an amateur geologist at the time. The word didn't even exist. And when he drew this, and a very conservative Victorian society started to look at this, they realized for the first time they couldn't use thousands of years to measure the age of the Earth. They had to use millions. And the point with the Hubble image on the right here, as Gary Vicon made out, that picture tells us we have to use billions of years to measure the age of the universe. These pictures have power. And more direct power. They have real bearing on us. We all know what this image is telling us. Images have power. And they tell us about ourselves as much as they do about the universe around us. And in case you wonder, we can actually measure that power. Here is the impact, the public impact that's tracked. This is like tracking how people use Cheetos or so forth. It's an advertiser's database looking at the number of headlines in the circulation, and it's back in 2009. It was the impact of the servicing mission when the astronaut crew went up to service. It was incredible, 2 billion impressions. One of the largest public events of the shuttle program, other than the tragic disasters. What really surprised everybody, including ourselves, when the science was released, the impact was even larger. People love the combination of science and exploration. It brings people in. So this was back in 2009. Today, Hubble still produces images and pictures and results. And if you actually just look at the data, this last year, in 2016, Several of these events reached over 1 billion people just from the results. And the point about this is that science plus exploration gives a resilient impact. It keeps on giving if you get it right.
Liftoff of Space Shuttle missions to Hubble and the position of Hubble into the deepest grandeur of our universe.
Graph on the right there is the number of publications per year from the Hubble Space Telescope. Many of you have seen this before. The orange are the number of papers produced in astronomical journals, refereed papers, that just come from the Hubble Space Telescope and the guys who applied for it. All those blue graphs are the number of papers that come from the data in the archive that gets reused. In fact, for some of the papers published in 2016 used data back in 1998. Because Hubble has been around so long, the scientific legacy is even more powerful. In fact, doubles the productivity, which actually has made Hubble the most productive science facility in human history, period. That would not have been possible without a partnership between science and exploration. There's a whole generation who've been brought up with the Hubble Space Telescope. It's just part of their everyday lives, like this young lady here.
I look up in space and see Jupiter. I couldn't really see Jupiter, but I could see it with the Hubble Space Telescope.
Kids are very tangible, very tactile. They understand it if they can see it, if they can touch it, if they can experience it. I can't take them out to outer space, but Hubble brings space into the classroom.
And of course, it isn't just Hubble that creates great attention. Times Square, landing of Curiosity. I was woken up at 2 in the morning by my kids. Dad, get up, we've got to watch the landing. You know, the tremendous interest in what NASA does and the ability to participate is something very powerful. You know, and this mission being built at Goddard, the narrative behind this mission, this incredibly audacious telescope, which uses all of the greatest technologies that you guys have, 10 new technologies had to even be invented. There's a narrative arc here that starts in the mine in Utah.
How tough is it to find beryllium?
It took us about 30 years to gather all the data and information to design and develop this mine.
And once the ore leaves this mine, is it ready for the folks at the James Webb Space Telescope program to use it to build the mirrors?
No, after the ore material leaves the mine, it is shipped to the processing plant about 50 miles east of here.
So it starts there and actually leads to inspiring a young engineer in California to work on missions like the James Webb.
I think everybody wants to do something, be a part of something greater than just what they can do alone. Building something like JWST is that. So what I don't understand is why everybody isn't trying to do it. Trying to be, you know, an engineer, work on these big projects, becoming scientists, you know, I mean, I don't know, what else would you want to do with your life?
Thank you, Amy Lowe from Northrop Grumman. But here is the central point, right? We know when you look up, so John Grunsfeld a number of years ago twisted my arm to come and give a talk with him in Bangkok. And I thought, this is a really crazy idea. There were riots. And we were driven in black SUVs into a big university in the middle of Bangkok, assuming that we'd be looking at an empty audience, and we would do our bit and go back home again. We were driven in black SUVs into this, and there were 700 people waiting to hear us speak in English about the Hubble and the James Webb Space Telescope. And when John says, you know that you can actually get these images on the web the whole place lifted up their smartphones. They had already downloaded it. And that's the point. Missions, we talk about, everybody worries, this angst, this sort of 1950s, 60s angst about how do we create new Sputnik moments. Well, you know, for this generation, missions like HST, Curiosity, JWST, Mars Curiosity, all those audacious things that deliver results at the moment, they create Sputnik moments across the globe. As says the ambassador from Bangkok, as says the British representative in Hong Kong many years later. You create Sputnik moments every time you do something as audacious as these missions. And this is the point. We know what the Department of Defense does. It's supposed to defend the country. Department of Education, educate. NIH, heal. What's NASA's job? Inspire. And nothing was more inspiring than this moment.
It's one small step for man, one giant leap for mankind.
I got up at 3 in the morning and walked down a moor in Sweden to try and get to the only black and white TV that existed at the time. More importantly, when the history of the species is written, this event stands there. And this isn't just a statement. This is an incredibly well-reviewed book. It's a sort of the definitive study of human evolution today. And in it, he says, this is not merely a historical achievement, but an extraordinary, even cosmic feat. And it was done by you. It started with the first Renaissance, when exploration and science began to wonder, you know, those ancients, they had this idea of the world, but we don't know. So let's go find out. The acceptance that ignorance was okay motivated Magellan to sail around the world, motivated Galileo to lift up a telescope to look for the very first time. That Renaissance led ultimately to somebody standing on the moon. A partnership of, you know, we don't know, better go find out. And we are actually at a second Renaissance now. We're at an amazing moment in our history. Science has reached an incredible point. Technology has reached an incredible point. We need, as a generation, to exploit this moment, the second Renaissance of our species. Here's the science. We found the Higgs. Now, that isn't going to do much for space. These accelerators are pretty big. Gravitational waves, the discovery. Einstein was right, there are waves. Now we'll have LISA, but we'll also have gravitational wave detectors across the planet will sprout up. The New York Times, a few weeks ago, a huge article on dark energy. This is about dueling space missions. This is WMAP HST versus Planck. It's a shared endeavor about dark energy. It's an incredible moment. But there is one area of science that NASA owns, that nobody else can do. Are we alone? It's a question we've been asking for millennia, reaching back in time, and at this moment in our history, we have the ability to do it. We all know about this result, TRAPPIST. Now, it's not exactly our sun, but it tells us there's a Mercury and an Earth and a Mars potentially around this strange red planet. It's excited the public, it's excited everybody. Scientifically, it's excited us. We've already taken the census. Kepler's done it. An enormous number of planets. In fact, we now know almost every star has a planetary system, and at least 10 to 20% of those probably have Earth-like planets in a habitable zone, i.e. where water can survive. It's not just out there. We're thinking of Europa, other plumes. You know, it was laughable a number of years ago that there might be life underneath those oceans if they are there. People could argue convincingly, no. However, new work. People like Nick Lane are showing that hydrothermal vents of a certain type create their own membranes and can actually form cells. So it becomes a possibility for the first time. There is a scientific question here that actually can be legitimately asked. We see water on Mars. What does that mean? We want to know. We know in our universe there actually are 10 to the 23. Actually, a few months ago it was 10 to the 22. But we then found there were 10 times more galaxies than we thought. So I've changed the numbers. That's an enormous number of stars. And physicists and engineers, when we sit here, we say, well, therefore life must occur, right? I mean, here is the picture of the universe. Something happened and life emerged. But, you know, we're not that special. In fact, Ed Weiler has been quoted. In fact, he got the number right. I know he guessed, but he guessed right. You know, given there are 10 to 23, it would be arrogant to think life didn't emerge elsewhere. That's a prevailing view amongst physicists and engineers. However, that's an arrogant view. If you're a biologist, an evolutionary person, and you look at this question, you say, not so fast. And in fact, this book, The Eerie Silence, quotes Ed Weiler, in fact, was motivated by Ed Weiler's quote, and points out there are so many things that have to happen to form complex life. We actually cannot calculate whether life will emerge. It could be once. None of us really know that, and that's the point. The only way to resolve this difference, there's an error here, an error bar in whether life emerged, which is roughly 10 to the 23 in scale. It's a better deal than dark energy, where we're 10 to the 120th. But observation can clear this up. And it's only through observation that we can clear this point up. And it is not given. And we actually know how to make this observation. Just remember, though, the Earth is incredibly faint. We have thousands of these planets, but they're actually not very bright. And if you actually ask how bright they are, actually, an Earth around a nearby star is fainter than the faintest galaxy in the Hubble deep field. And we need to take a spectra of said thing. And there's a very salutary lesson in profound measurements of such importance. And here it is, the Higgs. 2 teams, 2 ways to do it. In America, they used the tevatron. Maybe they detected it. The Europeans decided we need to do this properly. They put huge resources into it. You can see the comparison of the people. There's a person on there down to how big that is. And they nailed it. And that's where the Nobel Prize went. And that's where the discovery went. To doing this measurement properly. And if you ask, the wonderful thing about looking for life, we know what Earths look like. We know where all the stars are. You can just put an Earth around the star in the computer and ask, what do I need? The telescopes that we can imagine today, with the kind of rockets they're doing, sort of like a JWST, we might be able to do it. If we actually want to nail it, as the LHC did with the Higgs, we need a bigger telescope. We need something which is 2 to 3 times bigger to actually make the unequivocal discovery that we are no longer alone. This is not something you can do by half measures, because everybody will want to know. But we can't do this as scientists without the infrastructure that exploration gives us. We need rockets like this. It takes science to the next level, whether it transports people to missions to Europa, maybe one day people to Mars, and maybe ultimately find a place outside our solar system that is ours. We have 3 compelling narratives on science today. The search for life around other stars. Has life emerged in our own solar system? And can we send scientists to the surface of Mars, geologists, biologists, planetary scientists? These are incredible stories. not just scientific stories, but they're human stories. They're about reaching further. They're about taking people on a journey as important as Darwin setting out on a boat called the Beagle. Except this time, in this century, we can take people with us with all these communication tools. And the thing that brings all of this together, the thing that makes all of this possible, is partnering with exploration and the infrastructure that NASA builds. Because with these kind of rockets, we can do these kind of science, and it transforms everything we ever do. It makes a difference in the history of humanity. And nothing. No one has yet found words as profound as Carl Sagan's to describe what such a journey means. And I thought I would just finish with these, and then 2 more pictures.
What new wonders undreamt of in our time will we have wrought in another generation and another? How far will our nomadic species have wandered by the end of the next century and the next millennium? Our remote descendants, safely arrayed on many worlds through the solar system and beyond, will be unified by their common heritage, by their regard for their home planet, and by the knowledge that whatever other life may be, the only humans in all the universe come from Earth. They will gaze up and strain to find the blue dot in their skies. They will marvel at how vulnerable the repository of all our potential once was, how perilous our infancy, how humble our beginnings, how many rivers we had to cross before we found our way.
This was the iconic image of the 20th century. The first time humanity left its home planet. I mean, I still remember in the winter of 1968, my father, who was not an engineer, not a scientist, in fact, he taught history, rushing out to get the first time the Times of London had ever published anything in color. And he grabbed 2 copies of this to fold away for his 2 children so we would remember that day. Of course, the modern age is such that actually I lost this many years ago, but I found another copy on the web. So the modern world changes. But the point is still there. This was an endearing image. And maybe this is the image of another living planet that maybe my children, or maybe if I'm lucky, I will be able to give my grandchildren. This is an image that maybe transforms the 21st century, becomes NASA's legacy for the next century, and something only you and NASA can do. Thank you.